Hey guys, welcome to day 42 of Codeforces Everyday until GM. We are on problem 85 of the A20J problem set, just getting closer to completing this under 1300 rated problem set. Let's just jump straight into it. Okay, we start off with an 1100 rated. A new Die Hard movie had just been released. There are in people at the cinema box office, standing in a huge line. Each of them has single 25, 50, 100 ruble bill. A Die Hard ticket costs 25. Can the book clerk sell a ticket to each person and give the change if he initially has no money and sells the ticket strictly in the order? Okay, so we want to print yes or no. N equals int input, and then okay, A equals list map int input split. And then we're basically checking if we can successfully sell a ticket to everybody and give change to everybody. So if you start off with 50, okay, basically it seems like the golden rule here is if you start off with 25, then you're valid. Like you have some play or like counterplay to people paying 50 or 100, right? But there are certain situations where you don't need it. Like, for example, if there's only one person, well, if there's only one person, it's over, right? They don't have any change. So you have to start with 25. Okay. I'm thinking about a counter right now. Using a counter just to count the groups. 25 you never need change for. So what really matters is 50 and 100. Well, I guess the number of 25s does matter because that's how you pay off the 50s. You can pay off the 100s greedily with 50s and then 25s. It's basically a greedy problem. You want to greedily give change back with the highest denomination you can. So basically for let's do a counter from collections import counter. Instead of a list, now let's keep a list. We do counter. How do we do this? Counter A is equal to counter. And then for bill in A, okay, well first we gotta check if AO is not equal to 25, we just break and exit. Or we just print no and exit. I don't think we need this actually, because we'll take care of it in the for loop anyway. It'll just be slower. For bill in A, if, okay, there's three things it could be, 25, 50, 100. So we can actually just add an if statement check for each of these. If bill is 25, okay, if bill equals 25, elif bill equals 50, else. These are the three different choices we have. If bill is 25, then counter counter A 25 plus equals 1. Bill is 50. Bill 50 plus equals 1 counter if counter A25 is greater than 1, greater than or equal to 1, then counter A25 minus equals 1, else print no. Exit. So we don't actually need this. We should handle this. And then case when the bill is 100, we don't even care about counter 100. We just need to check if counter 25, if counter A 25 is greater than or equal to 3, or, well, if counter A 50 is greater than or equal to 1, and counter A25 is greater than or equal to 1, then we just do this 50, and then we do, and that's it. Elif counter A 25 is greater than or equal to 3. We'll just do counter 25 minus equals 3, else print no exit. And if all of this succeeds, print yes. Unless I'm messed up logic, it should work. If it's 25, we don't have to give any change back. We just bank the 25 as future change. 50, we bank the 50, and we check if we have at least 125 to give back. If so, we give it back. Else, we print no exit. And then if it's 100, first we check if we have at least 150 and 125. If so, we give them back. Else, we check if we have 325s. If so, we give them back. And we don't have to store 100 because it's kind of a useless denomination. we never give back a 100 denomination, right? And then if everything passes, then we can just print yes, call it a day. Seems like it worked. Okay, nice. One question down. Rank list. Another 1100. Another programming contest is over. You got hold of the contest final results table. The table has the following data. For each team, we are shown two numbers, numbers of problems, and total penalty time. However, for no team, we are shown its final place. You know the rules of comparing the results of two given teams very well. Let's say Team A solved PA problems with a total penalty time TA, B solved PB, total penalty time TB. Team A gets higher place than Team B in the end. If either solved more problems, okay, it is considered. Hey, blah blah blah. Too many words, I'll read it later. First line contains nk equals map int input dot split. And then inlines contain p. So for in range in pt equals this. Okay. A solved P problems with the penalty time T. Equals T. It gets a higher place than team B in the end. If either solved more problems on the contest or solved the same number of problems but in less total time. In other words, Team A gets a higher place than Team B in the final results table if either PA equals or okay, so basically they solved more or they're equal in time is greater. So this is like a pretty standard like constraint where tiebreakers are broken by time in these like programming contests, right? Like I was under similar constraints when I did C# programming for the BPA contest, but yeah. Okay, let's take a look at how to solve this. Considered that the teams solve the same number of problems. Okay, let's say X teams the task is to count the number of teams from the given list shared the K place. Oh, wait. Share all corresponding places. So that tied, if they're same solves, same time. Okay. So this is, oh, these are different teams. That makes sense. So this team solved 4 problems and, oh, plus 1. So nobody is first. Basically. This team solved 4 problems in 10 seconds. Or in 10, whatever the fuck unit T is. So 4 problems in time of 10, 3 problems in time of 20, 2 problems in time of 1, 1 problem in time of 10. So we look at these 4. These 4 are in first place, but since they're tied in first place, they're in second place, and there's 3 tied, so we just output 3. So this actually doesn't matter. It doesn't matter. Well, actually does, because that's how we find them. Right, okay, so these are in second place. This guy's in third place. These guys in fourth place. This guy's in fifth place. So that's how it works. That's how it counts out to be. And then for this one, this guy's in first. These guys, okay, first place, second. Oh wait, no. We're looking for fourth place. So first place, second place. Wait, what? Well, let's look at the note. Oh, so these guys take places 1 through 3. Fourth place, 5 and 6. Seventh place. Well, looking for second place. There are 3 such teams. Okay. I kind of get what I'm supposed to be doing now, so how do you actually like mark this or like handle this? Let me pull up a whiteboard. So I have this idea where I see kind of buckets right now. Like our places is 1 through N, right? And then wait, can you not just insert it in a list like A equals this, and then you insert PT into this, and then sort by P first, then T. And then okay, what? Cause there, I have 2. Okay, bin search. Well, binary search requires sorting. So, well, I'm not even thinking about bin search because after you put it in and sort it, you'll have like an order like this, right? You would just go to that index. So maybe 0, 1, 2, or like 1, 2, 3, or 1, 2, right? And then you just have 2 pointers. You check left to check right until you meet. If they're the same, you add one to print, and if they're not, you end that pointer. Right? So let's take a look on how to implement that. So we would have an array, a places or teams equals empty array, and then dot append. It's a tuple because this will never be modified. PT, and then teams dot sort Python sort tuples. Then by second element for ties. Well, faster is better. So how do we okay, well, reversed equals true. But how does that handle? Okay, let's just print this out. Oh, I hate how it does that. Okay, wait. Alright, don't auto run it. Okay. Just type it in personally then. 10 to 420. Oh, it's over. Okay. We'll go back. Uh-oh. I can't go back. Okay, let's just do 2, 2. Alright, I brought 2, 2 here. That's not good. 2, 2 needs to be here. Uh, oh, wait, this might be tech. Cause like, I don't know, I'm sure there is a way to do this, but I'm not actually too familiar. Like, I can Google real quick. But what I actually can do is just make T negative. And then it'll fix everything. And then at the end I just have to remove the negative sign. But I will Google how to do this normally. Let's see. Let me take this. Okay. So key. The most efficient way to sort by reversed first element and normal second element is just make the first element negative. Okay, well let's do that then. Because it doesn't actually matter. Alright, can I just do this? I think I can. Themes.sort print themes. One. 1, 1, -2, 2. Okay. Now we just check. What? Okay, we need I equals J equals K while teams I equals teams K and or teams J equals teams K, then I minus equals 1, J plus equals 1. print j minus I. Okay, if it's 0, 1, j is 1. Okay, j is 0, 1, 2 is 0. 2 minus 0 is 2 plus 1. Now, I need to handle cases where teams I becomes negative 1 and j goes out of bounds, but okay, expected output 3 received 7. Why is that? Oops. Okay. Teams K, teams I. This doesn't work. Right, because we increment both. Wait, so we can do while I is greater than or while I is greater than 0, we can check if teams I equal to K or teams K counter start 2 and 2 print equals 0, 2 print plus equals 1. While j is less than n, six n minus 1, print 2 print. Oh. Okay, this was very necessary to add. Push over. What's going on with this code? It just doesn't work. What's going on? Why does it go on forever? Oh, it's because I never decrement I. I minus equals 1. And then I plus equals 1. 410, 410. I. Okay, I equals k minus 1. J equals k plus 1. To print equals 1. These together. Still don't work. Because this is I, this should be J. Still doesn't work. Repeat it. 1. This doesn't work either. K plus 1. K is 2. 0, 1, 2. Oh, we need to do 0, 1, 2. 0. It's 2, 1, 0, 1. Shouldn't it just be given or equal to 0, and then I starts at k minus 2, then j starts at 0, 1, 2 at k, and then 6. If k is equal to 6, no, okay, this should be right. No. Okay, wait, why does it print this out? Yeah, because it goes through the break loop instead of here. That seems correct. Whereas this hits this edge case. So this didn't work. So we're at 0, 1, 2, or 1, 2, 3, 4. We're here. Okay, wait, we should probably print sorted. One, two, three, four. We're here. Check left. While I is greater than 0. We start at 2. 0, 1, 2. Equal. Add 1. So we got 1. I minus 1 here. Equal. Add 1. So that's 2. Minus 1 here. Not equal, so we move on. K. 0, 1, 2, 3, 4. equal, add 1. So that's 3. And then we should have 1 by default from this. So it should be 4. I don't understand. Our this loop didn't print at all. N is 5, minus 1 is 4, and our k is 4. So you're telling me it should be this? Oh, j is less than n. Yeah, it can't be equal to n because 0, 1, 2, 3, 4. If it's equal to 5, it's out of bounds. There we go. Okay. I don't know why that debugging took me so long, but this should be the answer. Question is it fast enough? I don't nest any loops or anything, so theoretically it should be fast enough. Wrong answer. Output 4. The answer is 1. 3. 1, 2, 3. How are we outputting 4 for this? Uh? 0, 1, 2, 3. Or 1, 2, 3. K should be... Oh, teams K should be K minus 1. Okay, yeah. Because K starts from 0, 1, 2... Yeah, that makes sense. Although, now that I think about binary search... What we're doing is, like... We start from here and then we go search each one by one. Binary search requires left, right, calculate center, and then we move either left or right to the center. So no, I don't think that works here. At least for the way I'm doing it. I kinda wanna see a binary search solution. I got it. Let's look for a binary search solution. Python 2. Oh, they use a.count. Well, I mean, That works too, right? Instead of having to deal with this, that's kind of annoying. Don't even have to sort. Right, so after here, you just do teams print teams dot count teams k minus 1. That's crazy. Wait, this didn't work. I guess you would still need to sort. Like this. 3, 4, 1. Yeah. Wow, I wasted so much time on this problem. This is the whole answer. That's crazy. Well, it's always good to look at other people's code. Let's just resubmit this. Alright. I guess I didn't really think about using .count because it's a tuple. I don't know why. Like, cause, yeah, like you would be able to count strings, you would be able to count int. I just didn't really think about using .count because it was for a tuple. It's not something I'm used to counting, you know? But I guess you totally could. Alright, one more question. Cut ribbon. 1300 DP problem. Polycarpus has a ribbon, its length is in. He wants to cut the ribbon in a way that fulfills the following two conditions. After cutting, each ribbon piece should have length A, B, or C. After cutting, the number of ribbon pieces should be maximum. Help Polycarpus find the number of ribbon pieces after the required cutting. First line contains 4 spaces in A, B, C. The length of the original ribbon, acceptable length of the ribbon pieces after the cutting. Correspondingly, numbers ABC can coincide. Print a single number, the maximum possible number of ribbon pieces is guaranteed that at least one correct ribbon cutting exists. What does this mean? So we take in a list. We're not taking in a list, we're taking in 4 different integers. N, A, B, C. And then after, okay, so ribbon length N, we want to cut 3 pieces into ABC. After cutting each ribbon piece, after the cutting, each ribbon piece should have length A, B, or C. So, fulfills the following 2 conditions. We should maximize ribbon pieces. Okay. So max length is 5. We can only get 2 ribbon. So don't we just greedily use the lowest, or what? A, B, or C. Oh. Each ribbon piece should so hmm. After the cutting, each ribbon piece should have length A, B, or C. After cutting, the number of ribbon pieces should be maximum. A, B, or C. Okay, I don't really get it because, like, in this case, if it's A, B, or C, can we not just maximize 2 and get 3 pieces? Like, we don't really care for having one of each, right? I don't really like the wording of this problem. Mm, oh, I get it now. So the reason why we can't abusively use 2 is because then we're left with a piece with extra that won't be length A, B, or C, right? Because it'll be if we do 3 twos, we'll have a length 1, and that's not 5. That makes sense. Okay, so how do we go about this? Uh, well, if it's DP, we need a DP array. But what is DP? DP is the... Okay, wait. Let me think. I'm thinking about making each of these like a base case. Right. right now, but how does that help me? Like if I have a ribbon of 8 and I have it, or like let's do a larger number, 16, and I have 5, 3, 2. Or what if I make it so that DP is the max number of pieces that you can. Okay, DP. Let's define DPI as the maximum number of pieces to make length I. So we want to find DP in. So our maximum number of elements is in. Okay, so we need to define the DP, and then it's times n plus 1. And then we need to define the DP as like something, like we can do -1. And then we need to build the DP for I in range. Oh, okay, our base case, DP is 0. It can't be 0. So we don't even need this, I don't think. For I in range, we start from 1 to n plus 1. If I is oh, I need to turn off sticky keys. Okay, how do we know which one to split it into? We have A, B, C. So so the length of the ribbon is less than A, B, or C, then we can't run that. Right? So like Fuck. Okay, so wait, let me Google. All subproblems must be solved to find the final solution. Okay. What does that tell me? Absolutely nothing. So how do we calculate dp in? dpi is the max number of pieces for length I. So the max number of if we cut a, the max number of pieces is I minus a plus 1. And then you're going to exchange a for b or c here. So the max, so we basically just try all three and then max. No? And we can save time by checking if a is, if is less than I, or is less than or equal to I. Hmm. Shit is so confusing. Hey, what is dpi by default? dpi by default is -1. I guess we do need a base case because if we're doing I minus A, if I is 1, A is 1, it's 0. So dp 0 equals 0. If A wait. Shit, it's so confusing. So 'say I had 7, 5, 5, 2. TP 7 minus 5 equals 2. dp 2 equals 1. Seven minus 2 equals 5. dp 5 equals 1. So 2 either way. Would it be... It'd basically be... We have 0, -1, -1, 3, 4, 5, 6, 7, right? And then start at 1. One is 5 and 2, 5. We need to skip 1 because 1 is not 5 or 2 or a multiple of this, so we skip 1. We go to 2. We start at 2. And then we I'm so confused. DP2. Wait. Oh, I need to see this in words. So DPI is max number of pieces to make len I. So a ribbon of length 2 should just equal 1. And then we go here. Ribbon length 3. It's not possible. Ribbon length 4. It's just 2 wands. It's 2. Ribbon 5 is 1, 5. Ribbon 6 is just 3 because it's 4 plus self. So basically, say we select A. So we're on I, and in order for us to select A, I needs to be greater than or equal to A. If we select A, we're calculating DPI. DPI equals dpi minus a plus 1. So 1 is the ribbon left, and then dpi minus a is the previous. So in this case, it would be, in the case of 6, it would be a is 2, 6 minus 2 is 4, so we would check dp4 plus a. What if it's invalid? If it's invalid, then we just return -1 and move on. So, okay, wait, if it's just I minus a. Let's say a was 3, I was 2. You get dp -1, which doesn't exist. So starting from 1, can we start from the minimum a, b, c? And then dpi is equal to max -1 d. Okay, well no, it'd be max dpi minus a plus 1 I minus b plus 1 I minus c plus 1. Well, it can't be minimum because this doesn't work. So we actually just have to check if we need to check something like if I is like this. A, B, or C. Not like this. A, B, C. And then we run like a dpi equals max thing inside of it. Oh, we can just do dpi. So this checks for case -1. And then this checks for case A, this checks for case B, because we can do this. If we select A, if we select B, if we select C, and then we just remove this. So if this, okay, so this is case -1, as in dpi does not exist right now. So dpi is -1, and then dpi minus a. So say say it was 2 and I was 6. Hold on a sec, let me just... 0, 1, 2, 3, 4, 5, 6, 7. So we start at min ABC, which is 2, 0, 1, 2. We're here. And we basically check which scenario goes into. For fair's sake, let's just say A is the minimum. A is 2. Oh, we can also just go in order. So we start with... So we don't check A, we don't check B. We check C. So dp2 is equal to -1 or 2 minus 2 plus 1. 2 minus 2 is 0, so dp0 is 0, plus 1 is 1. So -1 or 1. Well, we just choose 1. And then we go to 3. 3, we check all 3 of these cases. We get -1 for each of these cases. Right, because dp3 would return -1. dpi minus... Well, we wouldn't check A or B again. dp3 minus 2 is 1, which returns -1. It's -1, -1 plus 1 is 0. So we'd actually get 0 for this case. If it's 3, it should be impossible. I'm confused. Let's just print dp at the end. What am I getting right now? 0, -1, 1, 0, 2, 1, 2, 3. Zero, -1. A ribbon of length 1 would be impossible, yes. A ribbon of length 2 would have 1, yes. A ribbon of length 3 would have 1. Ribbon length 4 would have 2. Ribbon length 5 would have 2. In this case, ribbon length 1 would be impossible. Ribbon length 2 would have 1. Ribbon length 3 should be impossible. Okay, whatever. Ribbon length 4 would be 2. Ribbon length 5 would be 1. Ribbon length 6 would be 3. Ribbon length 7 would be 2. Length 8 is 4. Ribbon length 9 would be I want to see more scenarios with this like ribbon length 0. If it actually matters or not. So let's just do like a bunch of numbers. Let's do up to like 15 or something. I never actually hit this ribbon length 0 again, which is kind of surprising. But basically this would fail if this was 3. But then again, our expected output would be fail, but we never are supposed to get a failure. Wait, so technically if I do dpn, change this back to 7. Three, two, two, two. 0. We need to add a case. So, okay, so if 3222 is 0, then 5222 would be 1, which is just not correct. Does it matter though? Okay. I can't seem to find a case where our expected output is actually something. Because 8222 wouldn't even use 3. Three, two, 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 five, two, 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 7. Okay, but if it was 221, then you would just use 1 7 times. If it was 5, 2, 2, 3, then it'd be and if it was 3 by default, then it would just be 1. I don't think this case actually matters. Okay. Fuck it, just submit it and see what happens. Wrong answer. Okay. So it has to be this case, right? It's like there's multiple cases where we get this 0. Oh, I accidentally clicked tutorial. Wrong answer. The answer is 2. We get 5 somehow? Okay, I understand how we get 2. We just use 50 twice. But why don't we do that? Is there a way we're making 100 with 23 and 15? 23 times 2 is... No, you would need at least 5 23s, so you can't use 23 at all. With 15s, you can make 30, 45, 50. Wait, no? 30, 45, 60, 75. Wait. Fifteen times 6 is 90. So that's impossible. How are we getting this? Which 5 lengths are we adding together? Mm. $15. Oh. 15, 1, 16, 0, 17, 18, 19, 20. Wait. 23, 1, yes. 32, 31, 1. That's not it. 31. Okay, it's a 0 case. It's a 0 case that's causing issues. If dpi equals 0, oh my god, just set it back to -1. Right, because the only case where it should be 0 is on case 0. Otherwise, it should just be impossible. Okay. Let's kill off all of our other print statements. Okay. It worked. Jesus, that question was insane. Very mind-boggling question. I definitely have to bookmark that one. But yeah, I think that question alone took me like an hour. Crazy. 45 minutes to an hour. Still kind of hurts my head, but I kind of get it. This one's kind of it's kind of different approach than the other DP problems we've done, right? This one is you figure out all the solutions or all the DPs first. Instead of like building upon it. Like the other ones, like this is tabulation or whatever the fuck it's called. Right? Where like Kuramiya's stones, that one was memoization, where you build like you build until you hit like what you need. Right? You look at the current and you build the previous from it. This one was you just build all of them until in. For like you create the entire array first. So, or I guess you only create it till n. Well, I don't know. They're kind of similar. I don't really get it, but it feels kind of different. The way, or like this would be a bottom-up approach versus the other one would be top-down, right, or something. I don't really know how to explain it. I'm gonna have to look into it more. But we got the problem. So if y'all enjoyed this video, be sure to like and subscribe, and I'll see y'all guys tomorrow. Bye.